The last two sections in Unit 4 are all about parallel and perpendicular lines. This topic is going to come back into play in geometry, in algebra 2, and so many math classes in the future that what we wanted to do was actually break this into two sections. One section where we really just focus on what are parallel lines, what makes parallel lines special, how does that relate to the idea of slope, and similarly with perpendicular lines, what makes them special, how does that relate to slope. And then in 4.6 we're actually going to focus on, now that we know how to identify parallel and perpendicular lines, how do we tie that back to the rest of Unit 4 and write the equations of parallel and perpendicular lines. So today our essential question, how do we identify if lines are parallel or perpendicular? So parallel lines are lines that have the same slope, the same m value. Remember, if we have an equation in slope-intercept form, we can identify that from the mx plus b. If we have an equation in point-slope form, we can identify that from the number in front of parentheses. But no matter what, or if we have lists of ordered pairs, we can identify that by finding the slope using the slope formula. But they have the same slope. Thinking about what that means, slope is the rate of change. So parallel lines never cross because they are changing in exactly the same way. And what I mean by that is, if I was in a car going 65 miles an hour and another car was going 65 miles an hour, but they were, let's say, 30 feet in front of me, am I ever going to catch up to that other car? Well, no, of course not. We're going the exact same speed, but there's a distance separating us. So similarly with parallel lines, they're changing with the same slope. They're changing in the same way, but they're on different tracks, so they're never going to cross. So same slope, they never cross, and this little symbol that we use for parallel actually kind of looks like the double L in the word parallel. So sometimes you will see people write like line L is parallel to M. But this symbol means parallel. So how do we tell if two lines are parallel? Well, the most important thing is we're talking about here is their slope. So we need to look at their slope. So let's look at the slope in this example over here. So I'm going to color code these lines. Let's make this the purple line. Let's find the slope of the purple line. Now we could do this by counting the rise over the run. We could do this by using the slope formula, but they gave me a graph. So I am going to count the rise over the run. So from 3, 4 to 5, 5, I'm going up 1. That's my rise. And my run is 2. I'm going over 2. So the slope of this purple line is 1/2. Now let's find the slope of this blue line. To get from 2, 1 to 6, 3, I am going up. I gotta erase this. Hang on. That's better. I was having trouble seeing. I'm going up 2, and I'm going right 4. And if I simplify that fraction, I get the same slope. So what we could say is that purple is parallel to blue. And again, the reason that they are parallel is because they have the same slope. So for examples 1 and 2, we are given information about lines and we are being asked to determine if the lines are parallel. So what do we need to do? We need to find the slope for lines 1, 2, and 3 on number 1, and for lines 1 and 2 on number 2. Why don't you go ahead, this is a great opportunity to review slope. Why don't you go ahead and pause the video and find the slope for each of those 5 lines. So remember, for each of these, I'm using this slope formula, y2 minus y1 over x2 minus x1. So y2 on the purple line on number 1 is 2, minus y1 is 3. That's going to give us 2 minus 3 is -1. Be careful, watch out here in the denominator, 1 minus -4 is going to become 1 plus 4. So that purple line is going to have a slope of -1/5. The blue line, 1 minus 0 in the numerator, 1 minus -4 in the denominator. This is going to have a slope of +1/5. For For the red line, I'm going to try and squeeze this in over here. -5 minus -4 over 2 minus -3. So in the numerator, see, lots of double negatives happening here. I'm going to get -1. -5 plus 4 is -1. 2 minus -3 is 5. -1/5. So for number 1, we are looking for any slopes that are exactly the same. So something to notice, they're all 1/5, but they're not all exactly the same because they all aren't negative. So only the two that are exactly the same are parallel. So we can say that line 1 is parallel to line 3. They are both -1/5. Looking at number 2, I'm going to use green for this first line. So m equals -1 minus 3 over -6 minus -5. This is going to give me -4 over -1, which is 4. So my green slope is just going to be 4. I'm going to use this black color here for the bottom line. M equals -6 minus -2. That's going to become -6 plus 2. On the bottom, 2 minus 3. -6 minus 2 is -4. 2 minus 3 is -1. So this is also going to be 4. So line 1 is parallel to line 2. Now let's talk about perpendicular lines. Perpendicular lines are everywhere. In fact, the way that the walls are set up in your house so that the roof doesn't collapse is by perpendicular angles, right angles, 90-degree angles. So things that are special about perpendicular lines, in geometry, you will heavily focus on the idea about the fact that when they cross, they form a 90-degree angle. In algebra, we're really more focused about the line aspects of it more so than the angle aspect. But it is really important for you to know they form to cross a right angle. Look at the corner of any ceiling in your house. You're going to see a right angle there. They're perfectly crossing in a stable way, creating a 90-degree angle. Things that you should know about perpendicular lines. They have slopes. Again, this is all about the slope. It's all about that slope. That are opposite in sign, meaning one of them is positive and one of them is negative. And they are also reciprocals of each other. So for example, 2/3 and -3/2 are an example of perpendicular slopes because they are opposite in sign. One of them is positive, one of them is negative, and they are reciprocals of each other. Something kind of cool to notice is that because they are opposites and reciprocals, if you actually multiplied them together, you would get -1. So perpendicular slopes always multiply to be -1. The symbol that we use for perpendicular looks like an upside down capital T. So you could say that line 1 is perpendicular to line 2. Let's look at this graph and see, are these lines actually perpendicular? They look perpendicular, but let's check and see, are they actually perpendicular? So to do that, I need to count the rise and the run, or I need to use the slope formula. So let's count here. This looks like I'm going down 3 and over 6. So the slope of my blue line, -3 over 6, which is -1/2. The red line looks like I'm going up one, 2, 3, 4, 5, 6, up 6 and to the right 3, which is going to give me a slope of 2. So looking at these two slopes, I'm asking myself two things. Are they opposite in sign? Yes. Are they reciprocals of each other? Yes. So we can say that blue is perpendicular to red. So for these examples, again, go ahead, find the slope for between each of those sets of ordered pairs for lines 1, 2, and 3 on number 3, and for lines 1 and 2 on number 4. So the first line is going to have a slope of -1/5 on number 1. The second line is going to have a slope of 1/5. The third line is going to have a slope of 5. So Line 1 has an opposite sign from both line 2 and line 3. But two things have to be true: opposite in sign and reciprocals of each other. So the only two that are perpendicular here is line 1 is perpendicular to line 3. Go ahead and pause the video and work through number 4. So for number 4, the first line has an undefined slope. We get 0 in the denominator, and that is not allowed. The second line has a slope of 0. So think about what that means. The first line, the black line, is a vertical line if it has an undefined slope. The purple line is a horizontal line if it has a slope of 0. We can't really check for opposite reciprocals here because we're talking negative and undefined. Think about, though, if you had one arm straight up and one arm crossing over it horizontally, this is going to intersect to make a right angle. Even though their slopes don't multiply to be -1, because one of them has a slope that is undefined, these two lines are perpendicular. So line 1 is perpendicular to line 2. So something to note about that: a vertical line is always parallel to any other vertical line, and it's always perpendicular to any horizontal line. Similarly, any two horizontal lines are parallel because they have the same slope, 0. But they're also perpendicular to any vertical line. So wrapping up with number 5 and just summarizing the key parts of these notes, two lines are parallel if they have the same slope. So for number 5, it just says write any two parallel lines. So my favorite number is 3. So I'm going to just choose my slope to be 3. So I'm making up any line that I want. Y equals 3x plus 4. Any other line that has a slope of 3 will be parallel. And I could write that in slope-intercept form. I could write that in point-slope form. No matter how I do it, the only thing I care about here is this slope being the same for all of my equations. Perpendicular lines have slopes that are both opposite in sign and reciprocal. So I'm going to write two examples down here. I'm going to write down the one that we just did on number 4, x equals 4 and y equals 3, because these are perpendicular, because any horizontal line is perpendicular to any vertical line. Then I'm going to take my first equation over there, 3x plus 4, and I'm going to make up a different one. My new slope, if this is 3, my new slope would need to be opposite in sign and reciprocal of that. And my y-intercept can be whatever number I want. So y equals -1/3 x plus 5. So parallel lines, same slope. Perpendicular lines, the slopes are opposite and reciprocals of each other. Looking forward to supporting you with this in class. Thanks for listening.